Okay, well, welcome to the afternoon session here on the Thursday of AIAA SciTech. I'm glad to see the true human factors and human performance diehards out here ready to engage this afternoon. We have a fantastic panel here, and first of all, I'm Keoki Jackson. I lead the National Security Engineering Center, FFRDC, at the MITRE Corporation, and I'm delighted to introduce our panel here on human readiness levels. So first, to my left, Dr. Judy C. She is a systems analyst and human factors engineer at Sandia National Laboratories. Then we've got Ben Schwartz. Ben is the vice president for user-centered systems engineering at Monterey Technologies. And then at the end here, we've got Sylvan Bruni. Sylvan is the division director for performance augmentation systems at Aptima. So please welcome my panelists here. All right, I'm gonna do a little calibration here. Who is deeply familiar with the concept of human readiness levels? So I see one hand. All right, so in anticipation, we have planned a little bit of stage setting here. So I'm gonna ask Dr. C to give just a short overview, a few minutes on the HRL concept and what it means. And then I'm going to ask each of our additional panelists to chime in a little bit on what they're seeing right now that is exciting to them about HRLs and the development of this concept in the kinds of systems that we care about in aerospace. So, Judy, over to you.
Thank you very much for that introduction, Keoki. Yeah, so we contemplated that our audience might not know very much about human readiness levels, if anything at all. So we prepared a few background slides to talk about what they are and how they were developed. So the Human Readiness Levels scale is designed to evaluate, track, and communicate the readiness of a developing technology or system for human use. If you're familiar with the Technology Readiness Level scale, then the Human Readiness Level scale will be intuitively familiar. So the Technology Readiness Level scale is a simple 9-level scale designed to measure the technical maturity of a developing technology. The HRL scale complements and supplements that by saying, well, while you're developing technical maturity, you also need to think about the readiness of what you're developing for the people in the system to use. So it focuses on readiness for human usability. And the whole intent of the HRL scale, like the TRL scale, is that it will identify and mitigate not just human issues, but also system program issues early and often throughout the life cycle. So in sum, where the TRL scale provides assurance that the technology is going to function as intended, the HRL scale says, well, the human is also going to be able to use that technology as intended. And the idea is, as with the TRL scale, the HRL scale will provide a single numerical rating that communicates to the decision makers in the program the human readiness of the system. The HRL scale actually has a long history. The idea was first proposed in 2010. And then in 2015, the Department of Defense led a working group to develop some detailed descriptions for each of the 9 levels in the HRL scale. And 2015 was the time when I came on the scene. I heard about the HRL concept in a meeting that really had nothing to do with human readiness levels, but that concept came up, and I was immediately intrigued and just went off and running with that concept. And the first thing I did was lead some research and analysis at Sandia Labs to see if there would be utility of the human readiness levels concept for the work that we do there. And then, as with most things, one thing just led to another. And in 2019, I found myself leading a working group of human systems experts all throughout the US to really flesh out the human readiness level scale and test its utility and get it to the point where it could be a fieldable scale like the TRL scale. And then in 2020, I led the writing committee that developed the formal technical standard instantiating the HRL scale in a format that could easily be put on contract work. And I'll just say the working group, we had over 30 experts throughout the US, very diverse representation from all fields. And then for the standard itself, we wrote the standard in 2020, and again, we had a very diverse representation on the writing committee. The American National Standards Institute approved the scale in 2021, and we were very pleased to see that the Department of Defense formally adopted the standard as a Tier 1 standard in 2025, signifying that they view human readiness as essential for system effectiveness, safety, and interoperability. So we considered that a big win. And now this year, unbelievably, we are already up for reaffirmation or revision of the standard, and we are going to make some revisions just given all of the changes that have occurred lately in Department of Defense acquisition processes and reforms. So I do show the standard on the slide there. It is freely available and can be applied to any contract. Thank you.
Thank you for that introduction and overview. And we're going to dive much more deeply into the concepts and the applications here. But first, I'd like to go to Ben. And Ben, tell me what excites you about HRLs and your organization in particular, maybe a little bit of an introduction about what your organization does.
Yeah, absolutely. I have an example, actually, as a really good case study. It's an introduction. But really, the thing that I try to drive with the user-centered system engineering process is the importance of making sure the system is ready for human use in an operational context where it's going to be relevant for the users in their mission. And we can really help to enhance the system engineering process. And so the example I've got is Patriot. It's a really interesting case study, I think. You're all probably familiar with Patriot. It's been around since the 1980s. And it's gotten many upgrades and enhancements over those decades, including a fully automatic firing mode. We've been talking kind of recently about autonomous lethality in the DoD and whether or not it's acceptable, but we've had it in Patriot for quite a while now. And during OIF, Patriot was used 11 times. 9 of those were against tactical ballistic missiles. It had a 100% success rate against those missiles. And that really highlights just how effective that autonomy is and that technology was with automated target identification and tracking. But then in March 2003, a British fighter jet was misclassified as a missile and shot down. And in response to that, the Patriot units changed their standard operating procedures so that the system would stay in standby mode and give the commanders additional time to evaluate a track, decide if it was a threat, and then bring the unit up to ready to engage that threat. And then just over a week later from this tornado incident, the Patriot radars detected a potential missile. The commander, thinking that the next step was just to bring the system to ready and prepare it to fire while he evaluated the track, ordered the launcher to come up online. Of course, the launcher was still in automatic mode, and so as soon as the launcher was ready, it went ahead and fired, shot down a US Navy fighter jet, and killed the pilot. And it turns out that the initial track was a false track caused by radar interference. It wasn't even a real track, and this Hornet just happened to be in the wrong place at the wrong time. The Patriot missile locked onto it and destroyed it. And I think this is a perfect example to frame HRLs in a way that's kind of relevant to a lot of our present discussions about autonomy, because the TRL of the system, both the Patriot and the autonomy that was added to it, were very high. They were both field proven, obviously. And yet the human readiness level was insufficient. And it highlights a number of issues with adding autonomy to existing systems. In this case, we've shifted from a human in the loop and making a firing decision to a human on the loop model, but we didn't change the procedures, the mental models, and the training for the operators to kind of match that new concept of operations. And at the bottom, I have a citation for Dr. Hawley, who has written quite a bit about Patriot and these incidents in particular. He's an expert in the system. And he uses the word brittle. And brittle really accurately describes a lot of highly automated systems. The automation itself is brittle, especially when it gets into situations that exceed what it was designed for and its training. I think we see a lot with large language models right now where they hallucinate or they give incorrect information. And then what happens is the human is out of practice, or they don't have a full understanding of the system state, and so the human becomes brittle when they're expected to maintain vigilance over the automation or to take over when the automation fails. And so that's the perspective I want to bring to this discussion. When we talk about autonomy and these advanced capabilities, the HRLs help to make sure that we are integrating the autonomy and the human effectively as part of a larger system context. So I want to be really clear, it's not anti-autonomy. This technology can do a lot of really impressive things, and we're seeing advanced daily. It is pro-autonomy, but pro-human autonomy teaming and working together to achieve effective mission outcomes and to avoid situations like Patriot where misapplication can be disastrous.
That's a great introduction there, Ben. And I think many of us probably heard Jason Levins from Anduril, his discussion this morning, where he touched on a lot of these topics around autonomy, artificial intelligence, and human in and on the loop. You really set the stage for a discussion here about what does human readiness mean in an evolving world of AI and autonomy. So I think that's going to be great. Sylvan, I'm going to go to you. So maybe a quick introduction of your organization and then some of the things that got you excited as well.
Sure. So I'm a part of Aptima, which is a small business based all over the US, and we do defense contracting mostly, a little bit of healthcare on the side. And a lot of the work I do is managing people and managing technology, but I'm also a principal systems engineer. And part of that includes managing programs and a portfolio of projects in human-machine teaming. And so HRLs are really a strong part of the way we approach system design, development, maturation, and maintenance.
All right. Well, thank you. So we're going to just dive right in here. And I'm really struck, this seems like such an intuitively obvious and highly needed system. And yet, it wasn't until 2010 that it was conceived in 2015 when it really came into the first stages of fruition. So to me, that's a little bit astounding, and yet here we are now with a system that we can actually apply. And so I wanted to start off with just a little bit of the use case idea. So maybe you could talk a little bit, I'm going to start with Judy here, talk a little bit about some of the top use cases for government programs in particular, and I'm thinking the Department of War, but also the Federal Aviation Administration, NASA, and many other government customers.
Yeah, it turns out that the Army has been one of the early adopters of the HRL scale and the standard. So even before the Department of Defense or Department of War officially adopted the standard, the Army began applying the HRL scale within its existing user-centered design processes. And so as an early adopter, the human systems experts began applying the HRL scale within that process, and they demonstrated that it overlays easily and simply in that process, that it's not an extra burden. It's something that you can apply readily, and you can use the ratings to easily communicate to the program decision makers about the status of the human readiness of what's being developed. So the Army did some early applications on software modernization programs. One of them actually went through the entire HRL scale, so all 9 levels. There are some other programs that are in progress on the HRL scale. But as far as like the Federal Aviation Administration, they have been doing extensive research on how the HRL scale fits, again, within their existing processes to find out where are there gaps, where does it fit easily, and no modifications are needed. And I've actually been a reviewer of some of the documentation that's come out of that process, and I'll say they're really very close to being able to implement the HRL scale in their work, primarily to enhance safety. But if you take a look at NASA, so NASA has also been implementing HRLs. Again, even before the standard was released, they wrote into their Human Systems Integration Handbook, they wrote about the HRLs, and started doing some preliminary thinking about how the scale would, again, integrate into their existing processes. And just last week, I was speaking to someone from NASA Ames Research Center, who has been tasked to apply the HRL scale and then document the lessons learned from using that.
So that's great. So what we're seeing is really a broad set of applications. And I'll just note, I came directly here from a meeting with senior Air and Space Force leadership Monday and Tuesday of this week. And that included representatives from across the Joint Force and also our allies and partners. And there was a lot of discussion about technology, but what became very obvious was, everything needed to be set in the human context. And it was, yes, the people who were doing the design and the development, but it was the operators and the users. It was the people who were doing command and control of systems and systems of systems. It was the maintainers. It was, the passengers and the people that were working around these systems. And so as I was sitting through those discussions, it really highlighted for me the importance of having a systematic way to approach these. And by the way, for everybody out there in the audience, we're going to give about 15 to 20 minutes at the end for audience questions here. So please make sure, we'll have the QR code up on the screen, so get your questions to me. I see there's a couple come in already, and we'll look forward to getting into that discussion. So again, on this theme of use cases, is there anything you wanted to add, Ben or Sylvan, in terms of the use cases that your customers are coming to you with?
Sure. So if we can bring up the slide on the risks, I think this is one of the critical part in customer engagement across various use cases and domains. So I work a lot with the Army and Intel and things like that. And the key aspect is that if your human readiness lags technology readiness, you are going to fail. And this has been shown. The Patriot is an excellent example of that. That is why it is so important for the community to embrace this as a tool to manage risks. So your system is not going to be ready until it is human ready. Just focusing on the TRLs means you're going to be missing some particular cues in system design and development and maturation. We were talking about human-machine teaming. There is a lot that needs to happen there at the conceptual level, understanding needs and pain points, but then actually implementing them and closing that loop and seeing how it actually works, right? So this morning we were talking about the agile development process. That fits exactly with that, because that's how you're going to mature and then identify where those gaps may be. And as you identify them, you fix them and you advance, and your human readiness basically follows or matches your technology readiness as you develop. One of the critical parts here is to integrate HRLs as a gate criterion, just like you use TRLs. And I think that's important for program managers and leaders in ensuring that those are stated objectives at the different milestones of your project. So if you're following Agile, it's an end of sprint demonstration, it's a program increment demonstration as well. Those kinds of events need to have very specific human demonstrable evidence that you've reached certain advancement in the human readiness. And I think by doing that, you are moving decisions up, you're moving some costs up, but then you do not have to pay interest on poor design and poor decisions early on in your program that then require a rewrite or recreation of certain parts of your code or your hardware. So there is a lot there that mimics how MBSE works and how software engineering done in an agile way actually drives those better outcomes. So to me, this chart is what I use all the time, because it really speaks to how much risk are you willing to accept by ignoring the human side of the system.
Yes, and another way that our customers have been moving is going to experiments and field trials of things. And so rather than a bureaucratic review process, let's put it out in the hands of the users and the soldiers and the sailors and the Marines and see how they use it and how it meets their mission. And if you put a great technology that wasn't built around what their actual operational needs are, it's going to fail in that experiment. They're going to hate it. But if you put something in their hands that is built around what their actual operational needs are, has a high HRL, they want more of it. forget the rest of the development, put it in my hands now because it provides me value today. And so for project managers and for contractors who are developing new technology, that's a way to get people excited about it, to succeed in those evaluation events, and to reduce these risks along the way.
100%. I mean, I think if you have the opportunity to work with your customers on soldier touch points, or now they call it transformation in TIC.
Yeah, transformation in contact, and also
yes.
the experimentation events.
That's right.
Yeah.
So those are critical events and opportunities to actually see how the technology fares in the hands of the end user and learn and keep that loop going forward. Yep, absolutely.
Yeah. Well, let me pull the thread on that a little bit. So I think you've done a great job of highlighting, the risks if we don't do this. What I've observed is you get into these complex systems development and you get people try to divide and conquer. How do you make sure the HRL and TRL pieces really happen in lockstep and they're not off on independent tracks? Are there proven approaches, and do you have any examples of success stories?
Judy?
Yeah, so going back to the US Army applications, I think that's a great example of a success story where, again, the human systems experts just proactively began applying the HRL scale. They didn't wait for it to be put on contract. They identified how it would fit easily within the existing user-centered design work that they were already doing. And so while engineers were working on the technology and assessing the technical maturity with the TRL scale, the human systems experts began applying the HRL scale and also providing the comparable HRL rating as they went through the process. And what they found was applying that HRL scale was not an added burden, that it fit easily within the user-centered design process. And they're really, right now, they're our poster child for the application of the HRL scale because they've had such great success with it. On one of their systems, they reached TRL and HRL 9, and they're in the process now of collecting that data on, well, what do the users think now that it's fielded? Are they still satisfied with what was fielded?
Thanks. Maybe Ben Silman, how are you working with your customers to make sure that this has close to first pass success?
Right, yeah. Well, none of our contracts require it. And so it becomes a very useful internal tool and communication tool when we're doing program reviews or just communicating to program managers internally and government program managers. It's a way to kind of show, with some validation from an accepted government standard, the work that we've done and how we're maturing the human readiness of the system. Even though it's not a formal requirement and not a gate we have to pass, everybody's happy to hear the work that we've done as a way for us to take credit for what we've done. So we've used it very successfully kind of internally on a lot of our projects.
Yeah, I would double down on that. Certainly a great tool for communication, collaboration, and extracting from customers really what they want and what they need. I think our keynote speaker this morning talked a little bit about that as well, and we heard it in many presentations that it's so important to bring up those issues up front, but hear the operational community and what the needs are. What I particularly like about the HRLs is the flexibility. We're asking, are there specific practices to implement? The standard does provide enough flexibility to figure out what is the right way of doing that. And that can be a conversation and a collaboration with customers. In the context of what we've heard today in particular, it's indisputable that AI and autonomy is going to happen. Right? We're thinking about those hypersonic weapons happening. Human decision making is going to have to be accelerated by AI. We know that, but there is a right way of doing it, and we don't want to miss the boat on doing it the right way, because if we think the Patriot issues were big problems, it's going to be magnified tenfold, 100, 1,000-fold in the context of those high intensity battlefields. And so the flexibility that we have right now is to figure out, depending on that use case and depending on the context of operation, well, what should we actually look at and how should we actually check what the human workflows is, the needs are, et cetera. So there is a range of techniques that can be used for that.
I was scanning through some of the questions that have already come in, and there's one that kind of touches exactly on that. And it really gets after, what are some of the key human factors that engineers miss when developing technology. So how should people think about like what are some of the problems that this will help them avoid in that design cycle?
Yeah, there is a huge range of variability in the scope of human factors on a project, and it's obviously very dependent on the mission type, the domain, the environment, and so it's highly variable. And that's, I think, a key part of the HRL scale. Some of the early levels are understanding what is important for the mission at hand, what is the driving factor that impacts mission performance and mission success, so that we can make sure that we're developing the technology and the overall system to meet the operational needs. And that's, I think, a really key value of the HRL, to bring in that full perspective of not just human factors, but all the human systems integration aspects, the safety, manpower, personnel training, et cetera, and making sure you're actually bringing that holistic perspective into the system engineering process.
So if you were to think about it in defense terms, the whole .mil PFP process really comes to bear and gets touched on by the HRL approach. Any other comments on some of the things that you gave the Great Patriot example? Are there other, in that, you might say, well, that was a case where in one of these operations, the human didn't understand the state of the system that they were employing. What are you seeing in some of the other kinds of specific issues that this addresses?
Yeah, so another example that I like to use, early on in the Stinger missile development, the engineers assumed when they were developing that shoulder-launched missile, they assumed human performance would be perfect. All right, hardly ever happens, right? But the assumption was, when it gets into the hands of the soldiers, performance will be perfect. So they had a certain kill probability that that was their target, and they thought they were developing for that. And then they were surprised to find, when it got into the field, that the actual probability was about half of what they anticipated. And it was because they had not thought about the skills and capabilities and limitations of the soldiers who would be using the technology they were developing. And the soldiers found it very complicated. There were almost 17 different steps needed in order to fire it. And so they had to go back to the drawing board and redesign, taking into account the capabilities and limitations of the soldiers who would be using it. And that's one of the factors in the Human Readiness Level scale. Right from the get-go, it asks, who might be using this? In what roles? What would they be doing with it? And thinking through that, and then thinking through what are their key characteristics that will impact development.
That's a pretty stunning example where you got essentially your usefulness is cut in half just from failing to address some of these kinds of human integration challenges from the outset. So I think we've done a good job of maybe illuminating some of the use cases and I'd say the benefits to the end user or to the folks who are going to have to employ these systems. But one of the questions that's come in is, how do we explain the ROI of human resource or human readiness levels to business leaders? And in particular, bring it from the industry standpoint. Why is this helpful? How does this make sense? What are the use cases there?
Yeah, there's a constant challenge.
Yeah, I mean, back to what I was saying earlier, addressing issues up front will always cost less than downstream, right? So you can do the math in your head, spending, 2 designers doing 3 5-hour workshops, right? That's a certain amount of money to figure it right, the workflow, the understanding of the task and resources that the human in the system is going to need and what they need to achieve and outcomes, et cetera, compared to a full system rewrite, 5 months in. Those are 2 quantifiable things that you can apply to your own projects, and you will see the difference. It costs less to do it right first. And so that is the ROI that you're targeting. There was a very good discussion earlier today about technical debt and how that fits into it. And I think the human-related technical debt has such a cost downstream, because if you don't account for it, you go to one experiment event, right, one live action, and you put it out there, and the operators hate it, well, your contract might be terminated, Well, so much for saving, $10,000 up front for a design workshop that you want to do. And so those are the types of cost comparisons that really matter, because it's the longevity of your program and the involvement with your customer that can be at stake.
Yeah, and I want to be real explicit about what you said, the cost of this workshop and some of the design work up front. The design has to be done anyways, right? Someone's going to have to design the interface, do these analyses and trade studies. You might as well bring the right experts in the room who can do that. It's not going to add any more cost if you've got to do this work anyways. But a key objection we often hear is, well, I don't have a requirement for that, so why am I going to spend the money or the schedule on it? And I think a constant challenge that we have in industry is convincing program managers, telling program managers, we're not gonna delay your project, we're not gonna add significant expense, but we're gonna significantly reduce your risk and help you move faster, so that when you are delivering your product, you're doing the verification and validation, you deliver the right thing the first time, right? It's way cheaper to do it once, do it right, than to do it twice.
So all the program managers out there, I think the advice is, you could pay a little now, or you could pay a lot later, or even to the point of program cancellations. We've seen with, some programs have gotten to operational tests, and they really weren't suitable in the operational environment for the people that were using them.
Well, and I'll just add on to that one of the refrains that I've heard throughout the week is the imperative to go faster. And everybody's hearing that in whatever organization you're working in. Everybody wants to go faster. And I think the value of the HRL scale can be demonstrated there, because it is one of those foundational things that if you take some time up front to think about not only technical readiness, but also human readiness, you're going to save time later on, and those will be enablers for you to go faster. So incorporating the human from the get-go is one way to go faster.
There's a number of questions that touch on that. They're coming in. Before we go to that, I wanted to hit on, this came across in a couple of questions, and it was one of the things that we talked about in our prep. What looks different? So, I am in a systems engineering organization, or I lead a systems engineering organization, or a human factors organization, or a design organization. What changes? How, with the application of this, does my life as that engineer or that leader change?
Yeah, it's not a radical change. You're doing program reviews. A good program manager has the pulse on the maturity of the program and the risks, and they're getting honest information from their engineers, the development team, so that they understand the state of the system, they're burning down risk, they're managing issues as they come up. And this is one thing that is really important for program managers and engineering leaders to keep an eye on, that often gets overlooked. And so the thing that really changes is those leaders have the right information to make the right decisions. They have a fuller understanding of the capabilities of the system, the progress in the system engineering effort, and a truer understanding of the risk of lack of human factors or human systems integration.
And I would add to that, particularly for the software engineering community, less feature bloat, less design rot, because somebody said, oh, it would be good to have this, so let's add it, and let's add more stuff here, and then, well, it's not really addressing what the end users need, because we don't really know what they need, and we're just trying things out, and then suddenly your code base just grows and grows, and you have to maintain it, and it's not doing what you want, and obviously that also has costs downstream. So for them to have a much clearer picture of understanding what it is that we're doing and why. One of the best practices we've adopted is actually bringing our software engineers in those design elucidations so that they hear it directly from the operators. Like, I don't need this fancy gizmo over there. What I really want is this, right? Oh, okay, I get it. And then that really accelerates the design process and getting to actually an MVP that actually does what is needed, and then you can mature in the best practices. So it's a multi-dimensional cost saving and, I would say, management tool. Make people happier in doing the work that they're supposed to do.
So improve your customer delight, if you will, and save money at the same time. So getting back to what's in it for industry, it seems like that's a pretty powerful argument. So given where we started off this morning on autonomy and collaborative combat aircraft, and some of the things that you brought up, just now on this emphasis on going faster in all stages of the life cycle, Why don't we start unpacking some of that? So we got a question that came in, as autonomy options grow, and I'd say autonomy and artificial intelligence, recognize there's differences between those two definitions, but they're kind of coming along together. How can HRL approaches be used to grow the way we address automation and autonomy?
Yeah, so first I'd like to make the point that what I hear from a lot of people is we're going to automate the human out. And I want to emphasize that that's just not true. There is a human in the system somewhere. If you have automation, artificial intelligence, autonomy, there's a human there somewhere. And we did hear that this morning with the autonomous fighter aircraft. The answer was, well, it kind of depends how you define autonomy. There was a human in that system right now setting the parameters for how that aircraft would fly. It wasn't just, oh, take off, do this, and then come back and land. So I want to make that point. Regardless of your level of automation, there's a human in there somewhere. And sometimes the human is the designer who's making all those decisions that the end user would normally make in a system that's not automated or autonomous. But there is a place. So there is a place for human readiness levels in automated systems and in artificial intelligence. And I think there's actually a great need for something like the HRL scale when it comes to artificial intelligence, because right now we're tremendously focused on making our algorithms better so that the artificial intelligence will give us more accurate answers. There's very little attention. How is it going to be incorporated into our processes? How are people going to use it? And I'm sure that at your organization, you're hearing the same things I'm hearing. Oh, well, here's AI, go use it. But nobody tells us how, and nobody's ensuring that it is usable for what we need. There's just a lot of focus on the TRL, not so much on the HRL. And so I think that's kind of a challenge for everyone here, is to think about the artificial intelligence that you're using, your chat GPTs and so on, and think about where are they on the TRL scale, and then where are they on the HRL scale, and is that comparable?
Yeah, and maybe to continue along that thread, in the development cycle, both Ben and Sylvan, you talked about agile development. We talk a lot about CI/CD pipelines and things like that. Can you talk a little bit about how HRL melds into these kinds of modern development cycles, especially when so many of the systems that we're working on as an industry are largely software defined in a lot of ways?
Yeah, the whole push to digital engineering is about being able to simulate products in their operational environment, doing mission engineering and everything digitally to reduce risk before you start bending metal. And Stinger is a great example where they kind of pushed forward. Stinger actually was very early computer modeling and simulation of the tracker technology, extremely advanced capabilities from a technical perspective, but they didn't consider how the human performance would affect the operational performance of the system. And we can do that in digital engineering environments. I can simulate a human and understand their physical performance, their cognitive performance, their situational awareness and workload, and have that interact with the system. And so as you're designing the system, you're simulating it, you can understand how it will work with the human in the loop. And especially if you do that early and you do good trade studies on how the human will interact with the system, you can really increase the human system integrated performance rather than just throwing some automation or autonomy at the system and hoping the user will use it effectively in their mission. We can do good trade studies about what the right level of automation is, what the automation should be doing to take a burden off the human, and to really move from the automation and autonomy being a tool to really being a teammate. And I think we talk a lot right now about human-machine teaming, but right now it is a human controlling an autonomous system rather than a true teammate. And I think we can move there, but I think it's going to take good research and careful development of making it into a teammate.
Sylvan?
Yeah, once again, I think you covered some great grounds on the CI/CD pipeline and how to instantiate that. What I would definitely emphasize is considering performance measures as being human AI performance measures, not just AI or not just the human separately, right? There are a series of teaming constructs that can tell you about the performance of your system that are routinely ignored, that shouldn't be. particularly when we are considering very advanced levels of autonomy and automation in the critical systems we've been discussing. So I think emphasizing that and understanding that from the get-go, and then checking on those at those regular, agile ceremonies, or during your sprint review or a program increment review, those are the kinds of things that you should do systematically as part of your gate process.
And a question came in from the audience here, and to extend on that, to your point about how do you measure, what are some of the measures here? Like, how should they think about test in this HRL framework? So, you want to jump in on that?
How many hours do you have to talk about measurement of human performance? So
you didn't seed that question.
Right. There are plenty of published metrics that people can leverage. I think it's always good to bring in human factors engineers who know what you're talking about, and then looking at which ones are the relevant one for your particular problem. Lately, one of the things I've been trying to focus on is the human AI flow as a construct that includes trust and workflow adherence and teaming, like backup behaviors and things like that, as part of the general understanding of how the performance works. Like you said, moving away from human controls, this tool versus that tool, but more of a symbiosis type of relationship where there is significant decision-making authority or agentic authority on how the system behave. I think that's important. And there are plenty of resources out there to identify which measures make sense for a particular problem.
And I want to add on to that particularly when people are working with artificial intelligence systems, we tend to focus on metrics like the accuracy or the speed. You're going to be more effective. You're going to be able to do your job faster. But there's also this aspect that the HRL scale would bring in about thinking about what's the impact on the user. What's the user satisfaction? And so in some of these applications of artificial intelligence, I worry about, we say that artificial intelligence is going to do all those routine and boring things. Well, what does that leave the user with? They're left with those really hard, complex, complicated things that hurt your head. Well, that's going to have an impact on the user. If all day long that's all they're doing are those really hard problems and they never get a break with some of the easy things, but the HRL scale would help think through that. What is the impact on the user?
I know we've got a bunch of engineers who only want those really hard problems, but your point is exactly really valid, like as we think about what a person is going to be doing in these systems. We're going to go, there's just a bunch of questions here, but there are a couple things I wanted to touch on before we get to this. One is, obviously, you can't create the impact out of the HRL if we don't have adoption. So maybe I'd just love to hear ideas on what it takes to get this to the next level in terms of permeating through the aerospace ecosystem.
Sure, so I'll start, and I think that the Department of War adoption is the first stepping stone. I think that's a tremendous milestone for the HRL scale, because the Department of War is saying human readiness is on par with technical readiness. They're equal now. They're both important, and we need to devote attention to both of those. And so I think the Department of Defense is leading the way for other organizations now to do the same, with the Department of I'm sorry, I keep saying Department of Defense.
We're all still working on that.
I know, it's whatever terminology you prefer, but they're showing the way, and with them adopting the HRL scale, there's going to be a whole slew of industry contractors now following, because it's going to be put on their contracts. So it's going to promulgate in that way, but I think just demonstrating how to incorporate HRLs and sort of guiding the way, that's going to lead to more adoption.
Okay, and maybe on the industry side, like what does it take to get this built into processes and practices and teams?
Yeah, well, what gets required gets done, right, as we know. And so, there's been a push for standard KPPs, right? We have a net centering KPP. It'd be great to have an HRL KPP, drive key performance requirements for any system, from operational performance that includes integrated human system performance, and not just focusing on the performance of the technology. And that is going to drive contractors and program managers to emphasize how well does the system work in an operational context with a human in the loop.
Sylvan, what do you see in terms of really getting the application more widespread?
Well, I think it's going to be a combination of top-down and bottom-up, drive by people who are passionate about this and want to see positive outcomes in the use of critical systems. So, for example, there is the SAE 6906 standard for human systems integration, technically adopted by the DoD, yet doesn't show up in contracting, right? And however, if you have a customer who is passionate and understands the value of it, they will ask for that to be part of it. And that gives you the entire roadmap of how to do human systems integration and those types of activities and plans that you need to have up front and deliver on. And I think HRLs fit nicely into that, for example. At the same time, when you have companies that practice that, exposing it to their customers, like you said earlier, right, as a method of communication. Well, this is the way we think of the problem. We are following X, Y, and Z as part of our HRL plan, and then you educate at the same time your counterparts in programmatic leadership. That really does help, because then when they see the value, they're going to remember that and use it the next time around, either the same company or with another company. And so I think it's the constant back and forth of people talking about it and actually showing that there is value, and we have the receipts to show that it works.
So it sounds like there's going to be a little bit of a stick, if you will, in the contractual terms, but then there's that carrot in terms of really showing, and this is maybe even in the sales cycle, really showing the value to your customers. So I also wanted to talk a little bit about, we have the established HRL standard today. You've got some milestones up here for the FAA, but can you talk a little bit about where this is headed, like from 2026 and beyond?
Yeah, so again, something that I've been hearing all week long is that aerospace is kind of in a new era. We have new materials, new technologies, new designs. We have artificial intelligence. We have autonomy. And all of these things are taking us into a new area where we have to think both about the technology and the human. And so the HRL scale is going to be value added in that process. When we're trying to go faster with these new technologies and new materials and new designs, it's important to remember that if we take a step back and we start slow and we really think about all of the factors involved in this new thing that we're working with, then that will enable us to go faster.
Yeah, and I think, it's always hard to say, hey, we need to slow down to go fast. But maybe it's, we're going to speed up this piece of it so you're going to go faster along the entire journey. Anything else you want to add on that particular thought?
I second the points that Judy made, and also thank you, by the way, for leading the development of the effort. I don't know that we thank you enough for it. You mentioned the sales cycle, right? And it is a good human systems integration strategy can be a real differentiator, even if it's not required by the program. When we talk about how we can leverage HRLs and the kind of complex capabilities of a human-centered engineering approach, it helps us stand out because everybody wants to deliver better products. Nobody sets out to make a system that fails or that has fratricide incidents, and so we can bring this part of the process in to help strengthen a proposal, a concept, and to deliver the best solution for the warfighter.
So, what are, for this audience, what can they do in this next cycle of updates for the standard? Sylvan?
Well, I think it's volunteering to be part of the conversation, right? And I think it can take many different forms. Talk to us, and we'll redirect you to the right folks, depending on your level of availability. But I think there is a lot to be done to, disperse and spread the message. I think to make people aware. At least for now. One thing that is on my radar, and I haven't talked to you, Judy, about that yet, but surprise, is human digital twins. We're starting to talk a lot about those. Actually, tomorrow morning, there is a NATO study that is starting. I've been invited to be part of that. But I think that is also going to revolutionize the way we consider humans working with automation and AI. What is the implication on human readiness? When you have then suddenly a digital twin of the human users potentially as part of your system. I think that is a completely new take on human involvement and human readiness. And I think it's going to be important to really thought through what that means in terms of the testing and the V&V you do around your big systems like that. So
we're going to get away from these sort of 5 to 95% old school approaches and real, like, much more higher fidelity models of the human in the system.
That's right.
That's pretty exciting. Well, that actually tees up another area of interest. I mean, we've got a lot of students here at SciTech. We have a lot of researchers here at SciTech. So beyond the standard, what are some of the research questions? And you postured human digital twins here. What are some of the research questions that all the folks here should be thinking about as we're developing the underpinnings, the intellectual underpinnings, the science behind HRLs?
Well, I think there's a vast amount of research needed when it comes to looking at human artificial intelligence or automation interaction. So I think that's a wide open field where we really need tremendous research on what does that interaction between the human and the artificial intelligence look like? How can we maximize performance while also satisfying the user's need to feel like their job has meaning and purpose? Because again, I think we're focused very heavily on the accuracy of the algorithms going into the artificial intelligence and how effective those are, and doing better training on the algorithms, on the artificial intelligence. And we're thinking less about how the user incorporates into that system. So I think there's a tremendous amount of potential there for research.
From an integration perspective, I'm impressed with all the research that we heard about this week at all these paper sessions about all of the work that is being done for digital modeling and simulation of technology capabilities. We're talking about human digital twins. All of this work needs to be integrated really effectively, and I think that's an area that's rapidly maturing. It's a great area for researchers and for students today to integrate all these great modeling and simulation capabilities so we can do that holistic system and mission simulation effectively as early as possible.
I think there is also a big emphasis on AI literacy that needs to happen, and not just like at the surface level of knowing how to use ChatGPT, but understanding the underlying concept of how AI works, what it does, what it cannot do, in what operating envelope does it exist, for what type of application. More and more we are seeing end users that may be placing too much trust or understanding of the, or non-understanding of the limitations that the systems they are using can actually display. And that, I think, is a critical point where we need a lot more research and understanding of what drives then the system design and the interactions that Judy was just talking about. I think that's a key point that we'll see more work in the coming years.
Well, as somebody who started my graduate career in the human factors field and researching with, I'd say, much more limited tools, some of the things that you're talking about, for everybody out there, it sounds like this is an exciting time to be in the research of human performance and application of human readiness. We only have a few more minutes here, so I wanted to make sure I caught a couple of the questions here. One question it says, okay, we've talked about things like design and operations, but what about manufacturing? What about maintenance? Like some of these more hardware-centric areas.
Yeah.
How does the HRL apply there?
I actually have a great example of that. If we could bring up the slides again. This is a real-world case that happened at Sandia National Laboratories several years ago. And it's one of the case studies that we used when we were developing the HRL scale. During our joint working group, when we wanted to test the utility, we took some historical cases and we asked, would the HRL scale have helped here? And if so, at what level would it have detected these issues? So again, real-world scenario at Sandia National Laboratories. We had a weapon component that was undergoing refurbishment, and they were just having all kinds of problems manufacturing. And it got so bad that the entire process had to be shut down. And they spent some time trying to figure out, why are we having so many failures? So they brought in a human factors team, because most of the issues seemed like they were people related. And one of the big issues was that during manufacturing of this particular component, if there was any gel contamination on the outside of the component, later in the assembly process, it would just completely blow apart and have to be scrapped entirely, and you'd have to start over again. So to prevent that, they had human visual inspectors, and they asked these visual inspectors, well, take a look at this component before we go on and tell us if there's any gel contamination on there, and then we'll clean it up so it won't cause problems later on. The only problem was people could not see the gel contamination. So there on the left, under normal lighting, it's not visible at all. So they were asking people to do something that was not humanly possible. So the human factors team came in and they just experimented with various types of lighting, and they found out the gel fluoresces under green LED lighting. So a very simple fix. They went out and bought 3 green LED lights, $45 total. And now all of a sudden you can see on the right, the gel just pops out. So if there is contamination, now it is visible to the human eye. So I think this is a great example of how HRLs can be applied during production and manufacturing.
So a $45 investment as a
Yeah.
result of some human factors
Right.
engineering probably saved millions of
That's
dollars
right.
downstream.
Yeah.
Great example. I'm gonna want to wrap up here with a little bit of a lightning round. So as you look ahead, so here we are, SciTech 2027. What would you like to have seen happen in the year to come, or even maybe a little bit further out from here? So I'm going to start with Silva and come down back to Judy.
So my dream is SciTech 2027. I want to see a keynote speaker gloat about the HRL level they achieved for their system that they sold to the government, right? And say, we did it and we are there. I think that would be a great achievement and validation of value and the value proposition to the audience.
All right.
You know, in the Patriot example, I used the word brittle, or I borrowed the word brittle from a professor. I want to see more talk about things being robust and resilient, but not just talk about it, not just lip service. I want to see the experimentation. I want to see that we did these, Monte Carlo digital engineering simulations, and we showed in all of these failure modes, the human performance and the technology performance together was robust and resilient, and prevented issues, recovered effectively from those issues, and helped us design a really mission-effective solution. I want to see examples of that.
All right.
And I think I'd like to be able to come back next year and be able to report on exactly how the Department of War is applying the HRL scale. How are they incorporating into their processes, and what difference is it making? And then a little further down the road, I think I'd like to be able to say at some point, we are treating human readiness on par with technical readiness, and we're considering them in tandem and looking at both simultaneously.
So really hearing those examples of application, showing how that has created resilience and robustness, and then glowing about the results. That's where we're going to be in a year's time. So I got to tell you, I'm excited about that. My key takeaways from today, first of all, we have an amazing panel, so thank you. Let's give our panelists a round of applause.
Thank you.